Bismillahirrahmanirrahim. Welcome back to the foundations of generative artificial intelligence. In the last class, we had started the overview. Just repeating one thing about it. Our goal is to cover almost 70% of the course, 70 to 80% of the course at a high level, at an overview level. So breadth first, not at all depth first. In this lecture, hopefully, and maybe a part of the next lecture, अगर कुछ overflow हो गया. The reason for doing that is multifold actually. One, just so that you can get a sense कि वो क्या क्या चीजें हैं जो इस कोर्स के अंदर डिटेल में कवर हो रही हैं. Secondly, it will allow you to orient yourselves कि ये पूरी की पूरी पूरा जर्नी है क्या. So कौन सी जगह क्या चीज है. Some of the terminologies will be introduced as part of the overview as well. However, repeatedly I'll be restricting myself from saying too much about a particular topic because dig deep किया तो इनमें से हर topic जो है वो दो दो तीन तीन lectures का है. So therefore I'll be just trying to stick to the overview and also maybe I'll deny some questions. Feel free to ask questions. अगर मुझे लगेगा कि कोई क्वेश्चन ऐसा है जिसका आंसर देने में अगला आधा घंटा लग जाएगा तो I'll simply say wait until this topic appears again in let's say X number of weeks. ऑल राइट जी. सो हम यहाँ तक पहुंचे थे. अभी हम बिल्कुल ओवरव्यू के पहले स्टेज पर हैं. ये चीजें दोबारा नहीं आनी, एक दफा ही होनी है सिर्फ. सो लैंग्वेज का ओवरव्यू सिर्फ एक दफा है और उसके बाद जैसे ही हम एमएल स्टार्ट करेंगे I'll give you a reading as well जहां से आप इस सब कुछ को देख सकते हैं. एंड सेकेंडली I'll tell you कि ये वो जगह है जहां से अब हमारा प्रॉपर वो वाली चीज शुरू हो रही है जो बाद में रिपीट होनी है. ऑल राइट, जस्ट टू रिकैप, इन द लास्ट क्लास वी हैड रीच्ड अ पॉइंट. बाय द वे, मेरे कान में जो लगा हुआ है, दिस इज नॉट चैट जीपीटी टेलिंग मी व्हाट टू से. पिछली मरतबा हमने रिकॉर्ड करने की कोशिश की थी यूजिंग अ माइक्रोफोन. इट गेव अप ऑन अस इन द मिडल ऑफ द क्लास. सो आधी क्लास की ऑडियो है, आधी की नहीं है. Today I'm trying this while we are in the process of ordering a better microphone. So until then, just bear with me. I know it's sometimes annoying to see someone who's wearing a headphone while talking to you. So मुझे इस कान से आ रही है थोड़ी थोड़ी आवाज. Okay. All right. So we had started discussing about language in general, a little bit about what language is and maybe how we can define it. Obviously, each of those topics require lectures to go into the details, so we're just touching upon it so that we can just appreciate that the language is a major phenomena और उसको समझना और कैप्चर करना is not a simple task. और कोई क्लेम नहीं कर रहा कि लैंग्वेज सॉल्व हो चुकी है इवन आज के जनरेटिव एआई की जितनी भी कटिंग एज है उससे. सो वी नॉट इवन क्लोज, बट या वी इन द राइट डायरेक्शन, वी गोइंग इन द राइट डायरेक्शन एंड it's great that we're picking up speed. All right, so we started talking about Pakistan very briefly. Briefly, we said that we have 68 languages, living languages, and of these, 18 are endangered. So ये वो ज़बानें हैं जो कुछ अरसे के बाद शायद नहीं होंगी. Here is a list. बहुत छोटे छोटे नाम लिखे हुए हैं, but when you go through this list of languages जो पाकिस्तान में हैं, हम में से अक्सर के लिए ये बड़ी अजीब सी बात होती है. पहली दफा नाम सुने होते हैं उन जबानों के कि ये जबानें भी पाकिस्तान में बोली जाती हैं. So if I cannot read it from here, it's too small. But yes, Central Pashto and Burush, Sheski, and so on and so forth. So there are many languages. Many of these are mountain languages as well. So जहाँ पर जबानें बड़ी जल्दी जल्दी चेंज होती हैं. ये एक पूरा अलग टॉपिक है कि हाउ डू यू work towards preservation of a language. What does preservation of a language mean? लेकिन इतनी चीज जो हम पिछली स्लाइड से क्लियर कर रहे हैं वो ये है कि if you are lucky enough to be bilingual or multilingual, कोशिश करें कि ये गिफ्ट आपके साथ रहे because it leads to a different type of brain. So being multilingual or bilingual does not simply mean knowing two languages. It means that your brain is wired in a different way as compared to someone who's monolingual. And when you have at least a second language, the wiring of your brain makes you very apt for many types of tasks. Read up on these. मैं यहाँ पे अक्सर चीजें जो कह रहा हूँ उसके बीच में, so you'll actually find entire TED talks on those things. मैं आपको कुछ लिंक्स भी दूंगा इनमें से कुछ चीजों के that you can follow on your own just to dig a little bit more. अब आ ही गए हैं आप machine learning for language processing में, so it's worthwhile understanding language in more detail. Just to give you some idea, when you're doing a specialization in NLP, let's say you go for a PhD or a master's, then you're not just studying machine learning and AI and data science. You have to actually be trained as a linguist as well. So part of your training is as a linguist. So for example, as part of my PhD coursework, there were several courses which were deep courses in linguistics. So ये सारी चीजें आपको तब करनी पड़ती हैं. अभी हम इस कोर्स में नहीं कर रहे, लेकिन तब करनी पड़ती. Okay. So let's now look at some aspects of language processing जिन एस्पेक्ट्स का हम नाम भी बार बार लेते रहेंगे जिक्र भी बार बार करते रहेंगे so I'm just doing a very brief introduction of those aspects. If you remember from last time, we discussed that one of the goals of language might be to communicate ideas from one person to another person. So images, I have an image in my head, I have an idea in my head, I want to convey it to you. I have an emotion that I am experiencing, I want to convey it to you. I have a desire that I want to convey it to you. So these are the kinds of things that language is doing. We can discuss these things at various levels. There is the level of sounds. So, okay, here's a question for you. Do you think, so between the two modes of communication, speech and written form of communication, which one do you think is older? Which one came first? Okay. Do you think there is a small difference in the history जितने अरसे इंसान बोलता था और लिखता नहीं था या it would be a massive period जिसमें हम सिर्फ बोलते थे और हम लिखते नहीं थे? It's actually a massive period. Speech is our more instinctive, more ancient mode of communication जो बड़े अरसे से चल रहा है लिखना हमने बहुत बाद में शुरू किया है. Okay, of the two, speech and text, in terms of the three goals that we discussed earlier, the goal of communicating thoughts from one head to another, the goal of communicating emotions from one organism to another, the goal of communicating, let's say, commands and desires from one organism to another. Which one do you think is richer in handling the three? Okay, now you need to give me reasons. So raise hands. Okay. So speech allows you a richer set of tools to convey across finer shades of meaning. Okay. मैं आपको खाना खिलाऊंगा. तौबा करो. कभी भी इस जुमले में कोई सच्चाई नहीं थी. आप just said it. Okay. अगर मैं लिख रहा होता तो this is probably one of the few ways in which I can write it. I can also write मैं आपको खाना खिलाऊंगा as a question or maybe as an exclamation. So दो तीन चार मेरे पास options हैं. अभी emojis में अगर हम ना जाएं. Let's take it in speech. मैं आपको खाना खिलाऊंगा. 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 You see, I've just moved the stress from word to word and the meaning changed in every occurrence. मैं का मतलब कुछ और था यानी मैं खिलाऊंगा आपको खाना मैं आपको खिलाऊंगा तो और किसी को भी खिला सकता हूँ आपको खिलाऊंगा versus so you see how just and this is just one of the many tools that speech allows you. There is the tone going up, tone going down, tone remaining flat. Some of these are linguistically dependent. Okay, so the first level at which we deal with language is the sounds of language. From sounds we have words. So this now is more linguistic. Different languages have different interpretations of these sounds. So sounds form words. Sorry, what did I click? I didn't click anything wrong. Okay. From words, we get what we call sentences, one way of grouping these words. And from sentences, we get an overall discourse. There is a different branch of linguistics that deals with each and every level of these analyses. Interestingly, there are different levels of machine learning models which are designed for each and every level of these analyses. Okay, let's dig deeper. When we talk about sounds, or again, जैसे मैंने कहा, I'll try not to go into the depth of anything. This is meant to be a very high surface level overview. When we talk about sounds, we're dealing with a field of phonetics and phonology. So we look at human sounds, just the language sounds जिनका मतलब होता है, कोई linguistic मतलब होता है, एक वो sounds भी हैं जिनका linguistic मतलब नहीं होता. That sound did not have a linguistic मतलब, इसका कोई word नहीं था जो मैं बोल रहा था, जबकि मैंने जब कहा science, तो इस लफ्ज का कोई मतलब था, as opposed to जिसका कोई मतलब नहीं था, मीनिंग था, वर्ड नहीं था. Okay, so sounds में we have this theory that we can divide sounds into so speech into individual sounds. We call each and every one of those individual sounds a phoneme. What's a phoneme? The phoneme is the smallest unit of sound which can change meaning. Okay. Bal, मेरा बाल, सर का बाल. पाल, पाल पोस कर बड़ा किया, पाल. In Urdu, we found two sounds. Changing of them changes the meaning. So we say ba is a phoneme, pa is a phoneme. A would also be a phoneme because bal versus bal changes the meaning. Bal versus bil changes the meaning. Bal versus, let's say, bhool changes the meaning. No longer remains in Urdu, goes beyond Urdu, but it changes the meaning, and so on and so forth. So these individual segments, okay, what as machine learning people, what I would like you to focus on here is that we took something which is a long sequence. Mera naam Ali hai. We don't know what to do with this entire sequence. We don't know how to represent it. We don't know how to give it to, say, a neural network. So we say, okay, let's chop it up. Let's chop it up into small pieces. Okay, what could be those pieces? We can do it agnostically, just chop it up every 100 milliseconds. Or we could do it more intelligently, just chop it up at the stage where it transitions from one phoneme into another phoneme. Okay, so phoneme, the smallest meaning bearing sound unit, the changing of which changes the meaning. और obviously मैं यहाँ पे बिल्कुल clear कर दूं कि मैं precise definitions में नहीं जा रहा. I'm just keeping it at a very high level. Okay, sounds say we create morphemes. Okay, what's a morpheme? Morpheme is the smallest meaning bearing unit of language. So, for example, if I have a word boys, the part of it which say boy carries a meaning. There is a concept attached to it, the concept of a boy. And this S also carries a meaning. It does not associate with an object in the real world. It associates with a meaning of pluralization, more than one. So these two are two morphemes forming a word. So when we'll be discussing our own ways of chopping up words to give it to, say, a large language model, we'll be talking about these things that, okay, does this particular chopping make sense? Sometimes it will, sometimes it won't, but it will help if you know what these things are comprising of. All right, so morphemes form words, words form phrases. और हम आगे भी चल सकते हैं, खाली अगर इतना रख लें. The boy hit the ball, say, with a bat. Okay, in this sentence, we have multiple phrases. In English, it's fairly easy. So this is a noun. This is a noun phrase. So it's a determiner and a noun. This is a verb phrase. Verb, determiner, noun. The verb phrase itself comprises of a noun phrase, determiner, and a noun. So it's essentially forming a tree. So your sentence here is comprising of a noun phrase and a verb phrase, which comprises of a verb and a noun phrase, and so on and so forth. We can create these trees for parsing any sentence in a language. Some languages are simple, सादी सादी सी ज़बानें हैं अंग्रेजी की तरह की, जिसमें ये थोड़ा सा आसान होता है. Some languages are not that simple, like Urdu, which is a free word order language. Most things go, most orders of the words go, and there we have to come up with new methods of representing the parsing of sentences. मैं आपको खाना खिलाऊंगा मैं आपको खिलाऊंगा खाना मैं आपको खिलाऊंगा खाना आपको मैं and so on and so forth. Try saying the same in English and you won't be able to come up with so many permutations of it, which would actually make sense. Urdu also has a very uh, deep history with poetry, so some of these things start making sense as a poetic phrase rather than as an actual sentence. Okay, so phrases form clauses. Clause is essentially a type of clause, could be a sentence. So the boy hit the ball with a bat would be a clause which is also a sentence. There could be also clauses which are not complete sentences, but we don't need to go down to that level right now. Clauses form sentences, and sentences form the overall discourse. So when I say discourse, think of like an essay which has a lot of sentences, but there is an overall meaning associated with that whole essay. That's the discourse level analysis of that essay. Okay, let's dig a layer deeper. How many of you can read this? This is written in IPA, International Phonetic Alphabet. IPA has, so it's a notation where there is a symbol for every linguistic sound that we have known in the history. जितनी हमें पता है जबानों के बारे में, ऐसी जबानें भी हैं जिनकी अभी हमें साउंड्स नहीं पता कौन कौन सी हैं, उनका नहीं इसमें कोई तस्करा. जिनका पता है उन सब के लिए हर साउंड के लिए एक अल्फाबेट है, एक सिंबल है. I won't call it an alphabet. This is a the player hit the ball with a bat. This is the English sentence, the player hit the ball with a bat. Interestingly, at this level of analysis, there can never be an ambiguity of what sound was supposed to be uttered. That's one level of analysis, or what sound was actually uttered. So, for example, if I want to really understand what's the sound of a particular alphabet in a particular language, the right way of saying that is not fighting about it. The right way of saying that is record it, view its spectrograms, there is something called a spectrogram, and figure out from it what's being actually said by the native speaker. This is how we deal with things in this field. Okay, this forms this. So this is the level of sounds. This is phonetics. This is morphology. The player hit the ball with a bat. This is what we call syntax, sentence level analysis. And this is the eventual goal, the meaning. अब जरा वो याद है secret symbol? तवज्जो to the max. I had a thought I wanted to convey to you. The thought of a player hitting a ball with a bat. So I converted that into thoughts जिसने words दिए मुझे, और वो words को finally मैंने control के साथ अपना airflow control किया and I said it. Okay. Now, when you hear this sentence, the player hit the ball with a bat, is this the only possible image that could have come to your head? Give me an alternate photograph. By the way, here is an interesting experiment for you. Write the same phrase, give it to your GPT-4, ask it to draw it. And then ask it to draw it again with a different interpretation of the same sentence. And you'll see really interesting stuff happening. Okay, give me an alternate interpretation of this. Okay, baseball. So the player is not a cricket player, he's a baseball player. The player is not a male, it's a female. The player is something else. So बहुत सी interpretation इसी में बन जाएंगी, लेकिन चलें इतना भी इस डब्बे को नहीं खोलते, खाली दो रखते हैं. Give me another one. Go crazy with it. Okay, game character. Go further crazy with it. Bat. चमगादड़ उठा के मार दी बॉल पे. Why not? The same sounds, the same analysis at the morphological and syntactic level led to a different interpretation at the meaning level. So all of these are valid interpretations of the same sentence. This level at which we start looking at meaning is called semantics. So I actually have all of these for you. So sounds, phonetics, the rules of uh, putting the sounds together, which is actually learned statistically in our field from how native speakers deal with that, is called phonology. You can call it the grammar of sounds. Then you have words, morphology. Then you have sentences, syntax, and grammar, which again, uh, pure linguists come up with those rules based on reading the books of literature and things like that. We, computational linguistics people, the NLP people, we just take a lot of text and try to figure out the rules from that text. Whatever is written by people of that language uh, is what the rules are. Meaning, semantics, and then interpretation of the meaning is what we call pragmatics. Okay, let's do this. हमारे एक उस्ताद हैं जिनसे मैंने बैचलर्स के ज़माने में बहुत से कोर्सेज पढ़े. He's a chain smoker, just saying. Or I'm not saying कि आपको ये करना चाहिए. In no way I'm propagating what he used to do. One day we were in his office और हमारे साथ कुछ और असातिज़ा भी थे. I was doing my senior project. जिसे हम लोग final year project कहा करते थे. And here is the discussion that I saw happening. He was smoking a cigarette after another. The other professor who was in the room said, कमरे में बहुत घुटन हो रही है. What he meant, so अब सबको meaning भी समझ, so जुमला भी समझ आ गया, कमरे में बहुत घुटन हो रही है. I can do it at all of these levels. उसका मानी भी सबको एक ही समझ में आया है. It's the same at semantic level. Interpretation of the meaning, अब देखिए उसमें क्या changes. He meant to say cigarette बुझा दो, and the professor said खिड़की खोल दो. So the same sentence, the same meaning, nothing is changing. Only how the human chose to interpret that sentence changed. That's the pragmatics of it. Pragmatics is when the meaning interacts with the context and the environment. Okay. इसमें से कुछ भी आपने भूलना नहीं है, because अभी थोड़ी देर में हम मशीन लर्निंग के डब्बे खोलने लगे हैं. जब आप अपने ट्रांसफॉर्मर्स कोड कर रहे होंगे, यही प्रॉब्लम्स आपको भी आ रहे होंगे. Now you talk to these machines, you convey across meaning, and they interpret what you wanted of them. We generally say the hallucinations of a language model are caused by reason A, B, C, and D. We usually do not discuss this E, where the model might be completely and correctly interpreting the meaning of what you're saying in a very valid manner or a novel manner that humans have never interpreted it that way because it simply has read more, and it's giving a response based on that interpretation. कि आप सिगरेट बुझाने को नहीं कह रहे, खिड़की खोलने को कह रहे. So remember that when very soon we'll be trying to find out flaws in our models and trying to fix them. Okay, so these are the levels of linguistic analysis. This goes all the way from sounds, the most base level. Achha, by the way, this is not comprehensive. There are other things here. So at this level, there is also something called graphemics. So where we deal with the actual writing, which dictates the rule of the written alphabet. So Urdu में आप दो अल्फा दो letters लिखते हैं, वो जुड़ जाते हैं आपस में. They form a new shape. That shape is now known as a ligature. वो shapes बनना और shapes का shapes में morph होना, ये सारे भी rules के अंदर आ रहे हैं. That's also studied in a branch of NLP. जी. Great question. When we are differentiating between, okay, so there could be meaning bearing sounds, there could be non meaning bearing sounds. Even within the meaning bearing sounds, there could be linguistic sounds and there could be non linguistic sounds. For example, a sound may not bear a meaning, did not bear a meaning. Chalte chalte did not bear a meaning. I just hit my arm with my hand. I was thinking, did not probably bear a meaning. Maybe it did, maybe it didn't. But then a sound like or did bear a meaning, but it did not map onto a word. There is no linguistic unit in any language, hopefully, I don't know, as far as I know. सकता है किसी जबान के अंदर इसका word हो, but you're not saying out words here. You're not saying out something which could be chopped up into sounds which come together to form a word. अगर मैं इसको थोड़ा precise करना शुरू करूं, so there are, by the way, whatever I'm saying is very high level. There are litmus tests for everything. Can you take the sound, call it a verb or a noun or an adjective or something, and then can you play with it, convert it into a past tense, convert it into a future tense, convert it into a present tense, or if it's a noun, can you make it a plural? These tests allow us to find whether it's a linguistic meaning bearing sound or a non linguistic meaning bearing sound. Yeah. So, and this is when we talk about it here, we're talking about all known languages. So, but again, the field itself is a moving target because this definition of known languages also keeps changing even now when we start finding, okay, so in that mountain there was another community that speaks another language which is not a dialectical variation, it's actually a language and things like that. Ji. Yes, so the non-linguistic sounds, they, okay, that's a great question. And when you're saying in our analysis, what do you mean by that? Whatever model we're working with. Okay, great question. When we think about textual LLMs versus multimodal LLMs, we usually just say, okay, here is a stream of text versus a stream of sounds. What we usually do not think about is that when I'm talking to my chat GPT as in speech, using speech, now I expect it to understand sounds which do not map onto words. So my anger, my irony, my tone, the pitch, everything, I now expect that understanding from the model. Whereas when I was writing, I did not expect that because I did not have a very good way of conveying those things across. Okay, I can add emojis and it understands emojis. I can add maybe italics and bold and then some kind of a rule to, okay, there was an emphasis here or there was it. So we can do those things, but the richness, when the richness of the medium increases, the expectation from the model also changes. ठीक है, अब वो कर सके उसे फौरी तौर पे पूरा या ना कर सके वो एक अलग बहस है, वो है हमारी कैपेबिलिटी की बहस, लेकिन the ultimate expectation obviously is like that. Okay, यहाँ से अब हमने ट्रांजिशन करना है ML पर, but for those of you who are interested in understanding more about language itself, as I said, अभी तो हमने surface को scratch करना भी शुरू नहीं किया. I would recommend these 3 TED Talks. तो ये आपको मिल जाएंगी. The one is how language shapes the way we think. This is really interesting. Like you'll be amazed अगर आपने पहले नहीं सुनी हुई. The magical science of storytelling. This will go into the details of how language allows me to control, if you're not trained enough, to control the firing of neurotransmitters or the secretion of various hormones in your bloodstream just by doing what I'm doing right now, just by speaking. So the emotions you feel, essentially, I'm controlling the dopamine, the oxytocin. I'm controlling your stress hormones just by speaking. So this is really interesting. The guy will actually do these experiments live. So he's gonna read out stories to you and then make you, okay, this is what dopamine feels like. This is what oxytocin feels like. That's an amazing TED talk. So highly recommended. And then the third one is also very similar to the why do we feel what we feel. So ये अपने तौर पे कर लीजिएगा. हम अब मौजू बदलते हैं. यहां से आगे अब वो चीज डिस्कस हो रही है जिसका फर्स्ट पास है. So we're gonna overview the entire course in the rest of this lecture and the next lecture at some level of detail, but no deep dives at all. This is just meant to orient you on this map कि मैं हूं कहां और जा किधर रहा हूं. Most of this material is coming from J. Alimer's new book, Hands-on Large Language Models, Chapter 1. So it will be very closely following the book. You will also find the reference on all slides, जहाँ जहाँ books से हैं. So एक मेरी recommendation ये भी है कि वो book साथ साथ पढ़ना शुरू कर दें. It's very readable book. इसको usually हम ज़्यादा तब touch करेंगे जब हम intuition के level के ऊपर जा रहे होंगे. For deeper mathematical analysis, I'll give you other books and other references. But it is very readable, very useful, very hands-on. So साथ साथ कोड भी है, साथ साथ वो चीजें जो हम कह रहे होंगे वो कर भी रहे होंगे. इनफैक्ट अगर हम आज वहां पहुंच गए तो आज, नहीं तो अगली क्लास में I'm also going to give you the first code where you will use your own open source model. You'll deploy it, you'll run it, you'll talk to it, and this time you'll be controlling various aspects of it, like should it be creative, how creative should it be, in how many words should it respond. So not through the prompt, but through the actual commands in the API. So we'll do that. All right. So let's begin. Language AI. As we said, we will use interchangeably the three terms language AI or language technologies or natural language processing. So, precisely, language AI is a subfield of AI that focuses on developing technologies capable of understanding, processing, and generating human language. Okay, recently, पिछले चंद साल के अंदर, there have been many advances which allowed us to reach where we are right now. So even if we start at around 2000, where we started having these models. अच्छा, by the way, at this point, मेरी बिल्कुल so as in terms of the class, मेरी कोई expectation नहीं है कि आपको इनमें से कुछ भी पता है तो bonus है, नहीं पता तो कोई मसला नहीं. So by the end, you'll be familiar with each and every one of those things. Some of these things have entire lectures on them, जिसमें हम उनको detail में देखना. But there are some features, backwards, word to back. There are some capabilities like attention, and then these models like BERT or GPT, and then products like ChatGPT, which is not a model, it's a product. तो ये सारी चीजें इस पिछले 23 साल के अंदर होती रही हैं. This obviously that's not an exhaustive list. Now let's start diving deeper. खोदा पहाड़ निकला चूहा, उर्दू का एक सेंटेंस. I believe I can fly, इंग्लिश का एक सेंटेंस. This probably is खोदा पहाड़ निकला चूहा. This is also खोदा पहाड़ निकला चूहा. This is a spectrogram. This is a recording of a sound. This is a special representation where on the horizontal axis we have time. On the vertical axis we have frequencies. So this is going from 0 to 4000 hertz. And the color, the depth of the color, अगर ये light है तो इसका मतलब है वो frequency कम represented है, और अगर ये dark है तो इसका मतलब है वो frequency ज़्यादा represented है. So it's a 3D graph which has three things happening in it. When we study sound and speech, we rely a lot on these graphs. Regardless, ये ग्राफ अभी समझाना मकसद नहीं है. समझाना सिर्फ ये मकसद है कि when we're dealing with language, we're dealing with sequences, things which have a future and a past, but just these two things. दो डायरेक्शंस हैं, एक सेंटेंस है, खोदा के बाद एक वर्ड है, पहाड़ से पहले एक वर्ड है, आए से पहले दो वर्ड हैं, आए के बाद दो वर्ड हैं, दो डायरेक्शंस हैं जिसके अंदर कुछ ना कुछ हो रहा है. So whatever machine learning we develop for it has to be able to deal with history in both directions eventually. It doesn't make the word history doesn't make sense when we say the future history, but it will start making sense. So where am I going is my future history, and where I came from is my past history. So if my index is on the word I, then my past history is I believe, and my future history is can fly. Okay, all right. So the first thing that we're gonna learn, given a sequence, and because we don't know how to deal with sequences when we're giving them to a computer, is to learn to chop them up. How do we chop up these sequences into smaller units? How do we define those units? And once we have chopped them up, how do we convert them into a numerical form, a number that I can feed into, say, a neural network or a Bayesian model or an HMM or whatever? All right. So language as such is a very tricky concept for computers. देखिए कितना tricky. It seems that when I'm saying something, you can interpret it just by understanding the context. And when we say context, it means जो चीजें उससे पहले कही गई. बहुत ज्यादा जोर लगा लेंगे तो जी उससे जो पहले चीजें आपने पिछले आधे घंटे में कही हैं. आज की क्लास में if I use a new term and contextualize that based on something that I said early in the lecture, then my context window is 1 hour 15 minutes, which is the length of the lecture, right? But okay, let me do something with you. Kala dala. You laugh. Did I say that today? Did I say that in my lecture earlier? Did I define what it is? Would a person in US understand this context? Would a person in India say understand this context? Probably not. Would a person in Alaska understand this concept? You did, because it refers to the larger localized cultural political context of the country at this time in the history. If I said that 10 years ago, no one would have understood it. Maybe if I say that 10 years from now, ho sakta hai cheezein badal gayi ho, and maybe no one will still understand it. So there is a chunk of time in which this is appropriate, but you were able to understand it. This is the level of understanding you eventually want from a machine, the level of customization, localization that happened in that two words that I just said. Okay, so language is tricky. ये दूर दूर तक भी अपने जहनों में ना रखिएगा कि अगर आपकी कॉन्टेक्स्ट में जो कई हजार वर्ड्स की होगी तो आपके सारे मसले सॉल्व हो जाएंगे, नहीं होंगे, हाँ बेहतर होती जाएंगी चीजें. So text is highly contextual, loses meaning when represented by individual characters. और throughout the history हमारा एक मसला ये रहा है कि हम किस तरह से इन sequences को chop करें. All right. So we take the textual input, we do something with it, and we convert it into some form of a representation. ठीक है, ये कुछ नाम यहाँ पे लिखे हुए हैं जिन मकासद से हम इन कामों को करते हैं, but we'll understand that in a few minutes. Okay, terminology. When we take a sequence and we chop it up, the individual chopped up units are called tokens. Remember that. This word will appear in your either dreams or nightmares, depending on कि आप इसमें कितना इसके साथ वक्त गुजार रहे हैं. Tokenization is the process of chopping up your stream, चाहे वो speech की stream है या text की stream है, chopping it up into individuals. The individuals are known as tokens. ठीक है? Okay, so one really simple way of tokenizing text is to do it on the white space. तो स्पेसेस यूज करें, स्पेसेस के अराउंड हर चीज को एक टोकन समझें और उसको लेट से अलग अलग लाइन में लिख दें. तो अगर मैं आपको ये काम अभी माइक्रोसॉफ्ट वर्ड देकर कहूं या कोई एडिटर देकर कहूं तो आप उसमें बड़े आराम से कर लेंगे. यू गोना जस्ट रिप्लेस ऑल द स्पेस कैरेक्टर्स with enters and you'll have one word per line, give or take. What's the give or take? बचेगा क्या, क्या नहीं जाएगा अलग लाइन पर? व्हाइट स्पेस पे टोकनाइज करने में क्या अगली लाइन पर नहीं गया होगा? Yes, the punctuation marks. So full stops and your commas, which do not have a white space on both sides of them. Again, which is a convention that we adopted sometime after we started doing digital processing of language. This was not a rule in original English. कि किस साइड पर कॉमा के जो है वो अभी भी there are people who are like my professor, my PhD advisor, he always used to have double spaces. वो कहाँ लगाते थे सेंटेंस के शुरू में. He always used to have these double spaces. That was so annoying always. Like जब वो पेपर का एब्स्ट्रैक्ट लिख कर देते थे तो वो छोटा करने के लिए जब मैं सफे पूरे कर रहा होता था, my first job always was to replace all double spaces with single spaces. उससे टेक्स्ट छोटा हो जाता था. But he did that. So there are no fixed rules there. We have now made some rules and we started following those rules. But okay. So punctuations बच गई लेकिन बाकी सब कुछ हो गया. So if I take this sentence, that is a cute dog. This is splitting on white space, and each of these things, these green things are tokens. And here my cat is cute. My cat is cute के हर word को मैंने अलग कर दिया और ये मेरे tokens बन गए. This is the simplest form of tokenization. This is not the only form of tokenization. Tokens could be defined at multi-word level, at the phrase level, at the sentence level, or even at the document level. When I tokenize at the document level, my individual chunks are documents. When I tokenize at the paragraph level, my individual chunks are paragraphs. Make this mapping because अक्सर आपको books में यूं ये लिखा हुआ नहीं मिलेगा. By tokens हमारे ज़हन में एक idea बन जाता है कि it's word. No, it's not word. Far from it. Never equate token and word. These two are usually not the same, and these two are rarely ever the same. ठीक है? तो ये दो चीजें अलग अलग हैं. अच्छा, what we usually do now is subword tokens. We break the word further and we consider those broken things as tokens. So we'll see what those things are. दूसरा मसला. Do you think this white space tokenization will work for all languages? तो दो नाम तो आपके सामने ही लिखे हुए हैं और एक के बारे में शायद आपको भी आज से पहले ये ना पता हो. So Mandarin does not require spaces. It does not have spaces. You cannot tokenize on spaces for Mandarin. So when I say, okay, do multilingual, it does not mean कि इसका मतलब है कि बस अंग्रेजी का टेक्स्ट हटाया और फलानी ज़बान का टेक्स्ट पेस्ट कर दिया. Your systems in their core may not be able to support that language down to the very first level of analysis, which is dividing the input into tokens. ठीक है, तो लिहाजा फिर इसके लिए करते हैं कि यहाँ पे टोकनाइज करते कैसे? We're going to do that. So our first stop after starting the course, after the review overview ends, Our first stop would be tokenization, and we'll be looking at multiple ways of tokenization, including the tokenization which is used by your popular LLMs right now. Urdu also does not require a white space always. Urdu has this interesting property that there are certain types of characters, when they're placed next to each other, they change shape and they merge. And there are certain other characters, when they're even placed next to each other, they don't change shape and they don't merge. For the words, for the characters that don't merge, in original Urdu, we do not require an actual space between them because they don't merge. We don't care. So even जो शुरू के टाइप करने वाले उर्दू के थे, वो अलिफ के बाद अगर लेट से दाल लिख रहे हैं, पहला वर्ड अलिफ पे खत्म हो रहा है और दूसरा वर्ड दाल से शुरू हो रहा है और अलिफ और दाल नहीं जुड़ते, they don't need to put a space there. So the white space tokenization does not always work for Urdu. For modern Urdu word processors और अब हम जिस तरह लिखने लगे it works, but know it कि अगर आप उर्दू के साथ काम कर रहे हैं और किसी OCR की आउटपुट ला रहे हैं या कुछ और कर रहे हैं, you may face problems with white space tokenization, but again, everything in due course of time. All right, आपने टोकनाइज कर दिया. सेकंड कॉन्सेप्ट, बाय द वे, जहां जहां मैंने रेड किया हुआ है ना, दोज आर द थिंग्स यू नीड टू रिमेंबर. मैं इसके बाद से वो टर्म्स यूज करना शुरू कर दूंगा. आज की क्लास वो आखिरी क्लास है जब मैं चीजों को वर्ड कह रहा हूं. मैं इसके बाद टोकन ही कहा करूंगा. सो यू रियली नीड टू रिमेंबर व्हाट अ टोकन इज. सो इट्स एन ओवरव्यू, बट एन ओवरव्यू वेयर व्हिच आल्सो एक्सपेक्ट्स यू टू रिमेंबर सम थिंग्स. Okay, so after we have tokenized, we can do a very simple step of finding out the unique tokens. So the set of unique tokens that I have in the text that I tokenized is called the vocabulary. And each unique vocabulary item is known as a type. तो दो चीजें हो गई, टोकन और टाइप. टोकन्स क्या हैं? चंक करने के बाद इंडिविजुअल्स. कितने यूनिक इंडिविजुअल्स हैं, ये मेरा vocabulary साइज है. और हर यूनिक इंडिविजुअल एक vocabulary item है जिसको मैं टाइप कहूंगा. So tokens and types, two things that we'll be talking. By the way, at this point of analysis, there is, if I say a dog played with other dogs, the dog and the dogs in this particular case. So अगर इसमें टोकनाइज करूं तो टोकन्स क्या है? A dog played with other dogs. ये सब अलग अलग टोकन्स हैं. टाइप्स कौन कौन सी हैं? ये डॉग और ये डॉग पे मसला पड़ेगा. Is it the same type or different types? They are different types because their spellings are different. So when we are dealing with types and tokens, we're doing a surface level analysis, not a deep structure analysis. At a deep structure, the dog and dogs are the same word. They share a morpheme, dog. But when we are doing a type and token analysis, we simply look at the surface form. So play and plays and played are different tokens. They are different types. Whereas जब deep structure analysis हम कभी कर रहे होंगे तो फिर हो सकता है हम इन चीजों को कभी combine कर दें. All right. Now that we have this, so आपको यहाँ पर ये दो sentences के लिए ये vocabulary भी नजर आ गई. ये सारे unique words थे जो इन दो sentences के अंदर थे. So we have now our tokens and we have our types. Okay. Now let's see how we can represent them in a way that a computer can consume them. A neural network can consume them. By the way, जो मैंने last class में आप लोगों के सामने अर्ज किया था, दरखास्त की थी कि रिवीजन खुद से करके आ जाना, मैं रिवीजन नहीं करवाऊंगा. So there is no revision of neural networks built into these lectures. So वो जो machine learning का burden है, वो machine learning का आपका burden है. So it would be really helpful अगर अब तक नहीं किया और अगली क्लास में आने से पहले आप बैक प्रोपेगेशन के मैथ वाली जितनी मेरे लेक्चर्स की वीडियोस हैं वो सारी देख कर आएं, ताकि वो सब चीजें आपके फिंगर टिप्स पर हों, उसमें कुछ भी रिवाइज करने की जरूरत ना हो. What's the forward pass? What's the backward pass? What are the gradients? How do the gradients move in a particular direction? What's the stochastic gradient descent? You should know what atom is. So ये सारी चीजें, so मैंने जब इस दफा ML पढ़ाई थी तो एडम का जिक्र किया था, बहुत डिटेल में नहीं किया था. But if you know momentum and if you know adaptive learning rates, you're good. वहां तक फिर अगर आपको आता है तो आपको सब समझ है. इसी चीज की हमें जरूरत है. एडम को मैं थोड़ा सा और रिवाइज जरूर करूंगा. Okay. All right. So now I want to take this sentence and convert this sentence into a form that is consumable for a computer. And this is the first time we're bringing out our vectors. So we have something called the bag of words. Bag of words simply means that we have a vector. So it basically it starts out with something called a one hot vector. So there is a word, say the. We take a large vector which has, say, all words of the vocabulary. So suppose my vocabulary started with the word and there was and then so on and so forth, all the way to, let's say, zoo or Zulu or whatever. This was my total vocabulary. Somewhere in this vocabulary is the word the. A one hot vector simply means there is just a single hot entry, single one entry here. So everything will be a zero except for the entry in front of the. This is a one hot vector. So I can take a word. If I have predefined my vocabulary, I can just mark the spot where that particular word occurs, mark it as one, and that's a one hot representation of, say, my. I can do the same with cat, I can do the same with is, and I can do the same with cute. Now that I have these separate one hot vectors, I can just add them up and I get a bag of words. For example, the dog and the cat. So you get a one hot vector for your the, one hot vector for the dog, another for the, another for cat. So dog, for example, यहाँ कहीं one है, और and जो है वो यहाँ कहीं one है, और the again यहाँ कहीं one है, or the cat is यहाँ कहीं one. So these are my separate one hot vectors. If for the entire sentence now, if I add them up, I get a vector which has a one in the place of and, a one in the place of cat, a one where dog is, and two where the is, because there were two does, and so on and so forth. This is what I call a bag of words. A bag of words is essentially a multiset. So a set has uniqueness property. Each entity could be just one. In a multiset, we can have repetitions. The way we store it is that for each repetition, we just store a count. So if we have 3 of something, we just say 3. If we have 10 of something, we just say 10 instead of repeating them 10 times. Everyone with me? कुछ थोड़ा सा ये आंखों में नींद नजर आ रही है. मैंने अनाउंस्ड क्विजेस रखे थे, लेकिन इसलिए नहीं रखे थे कि आप सो सकें. तो ऑल राइट, ओके जी. Yeah, it's not a good representation. Yes, yes, great point. It's not a good representation. It works. So it works in a particular scenario. That's why we still have it. We don't directly use it. This is just the first stepping stone. We're going to reach a good representation soon. Ji. Yeah, so the vocabulary. So the vocabulary could be either defined as all words in the English language, which means that your vectors would be huge. Okay, how many words are there in the English language? अंग्रेजी तो कम से कम वो चीज है जो तुम लोगों को आती है. उर्दू पे तो तुम लोग बुरा मान जाते हो ना, पर अंग्रेजी तो तुम लोगों को आती है. अंग्रेजी में कितने वर्ड्स हैं? Sorry? Yeah, so with any rough idea, is this a well-formed question? अंग्रेजी में कितने words हैं? Am I asking about the size of the Oxford Dictionary? In which case I'm talking about not even vocabulary, I'm talking about something even deeper, because play, plays, and played have just one entry in your dictionary. So I'm talking about something else that I've not defined here, which is known as a lexeme. वो हम नहीं अभी पढ़ रहे थे, so don't worry about it. It's just a term. बर्दाश्त कर लें. Your dictionary entry. So, but अगर मैं इस तरह define करूं जैसे यहाँ पर tokenize करने में किया है, तो we're talking about millions of words. One, because ये बढ़ते जा रहे हैं. Two, because typos भी words होंगे. Because the way you're defining it is essentially just chop up the text and take every unique entity and call it something. So जितने typos हैं वो सारे के सारे words बन जाएंगे और उसके बाद नए आने वाले words भी होंगे. अगर यूं define करके ये vocabulary define की तो ये किसी भी GPU से handle नहीं होगी. ये vector किसी चीज में fit नहीं आएगा. So therefore, the actual practice is that we find the vocabulary from the documents themselves. This was the practice 15 years ago. The practice now is that we borrow the vocabulary from some model which has already done this for us. So we say, okay, just get the vocabulary from the internet. So आगे terms इसको देंगे, but when you say, okay, I'm using BERT as my source of embeddings, then whatever that model encountered in terms of vocabulary is the vocabulary of my model. Yes, extremely sparse, really bad. Yes, 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 बिल्कुल बिल्कुल. Yeah, this is sparse. We hate it. We agree. All right. So you have your bag of word representation, and you can use it to give it to a neural network and play with this and predict something on the basis of this. Okay. So the bag of word model aims to create a representation of text in the form of numbers called vectors, या vector representations. This is also known as representation learning in some sense. यहाँ पे वो learning fixed है, उसमें कोई learning aspect नहीं है. It's a deterministic one-on-one mapping, but it's an alternate representation. ठीक है? So when we start out with a base case, it's usually boring and dry like dirt. So that's what it is. Let's get to something more interesting. All right. Now, one of the biggest problems with your bag of words, in addition to the sparsity issue, which you focused on as a computer scientist, and you did not focus on, because you're not linguists, you did not focus on the other big elephant in the room, which is it has no idea of the meaning. You just chopped up text, put it all together in a bag, and then gave it to someone and said, what does this document mean? So that's almost like if I take a book, a page of a book, cut up all individual words, put it in a bag, shuffle it, give it to you. I need an assignment where you explain what this document said. This is essentially what you're doing when you're giving a bag of words to a neural network and asking it for the meaning. So it has no context. It has, but okay, चले, इसकी बुराइयां तो हम बहुत कर सकते हैं. Does it have something which we can usefully use? So let's assume I do give you the page of the book all cut up in individual words in a sack and ask you, what was this document about? Now, put yourself in the shoes of a neural network or a model. Tell me how would say what this document was about, or do you know nothing about it? Because the words have been shuffled, you know absolutely nothing about it. क्या इतने बुरे हालात हैं या you do know something about it? Raise hands, raise hands, raise hands. मुझे दूर के लोग भी अच्छे लगते हैं, वो भी मेरे सगे स्टूडेंट हैं, मेरे सुतीले स्टूडेंट नहीं हैं. दूर दराज से मुझे कोई हाथ चाहिए जो आपसे भी दूर. या if you guys are thinking सर मेरी बात तो नहीं कर रहे, तो I'm looking straight at you. आप ही की बात कर रहा हूँ. ओके अभी दूसरी क्लास है, अभी तुम लोग ड्रॉप कर सकते हो, अभी मैं खुद से वॉलंटियर नहीं करवाता. ओके सर आपने हाथ खड़ा किया. ओके ओके ग्रेट, दैट्स अ गुड पॉइंट. गिव मी एन एग्जांपल. किस वर्ड से आपको क्या पता लगेगा सेंटिमेंट का? लविंग इट. एक्सीलेंट. फर्स्ट ग्रेट पॉइंट कि वर्ड की फ्रीक्वेंसी may be a good indicator. Okay, so if the words, if we just put them एक कॉपी पे सामने अपने रख दें उनको, उसके बाद एक एक वर्ड जहां जहां आ रहा है, so let's say enthusiastic 4 दफा आया है उसमें, या loving it कुछ 4 दफा आया है उसमें, it तो नहीं था, हरी वर्ड love या loving था, so that means कि कोई पॉजिटिव बात हो रही है. Okay, so ये पॉजिटिव सेंटिमेंट बता सकता है. However, how about every time when they used it they were saying not enthusiastic, never loving it? So yes, the frequency of the words might be an interesting indicator, because but the loss of context, because the language has this opportunity of saying, in fact, this is not just word level. Good, not good. This movie is great, but, and now you reverse it. So the moment you have a but in there, that means कि आपकी sentence का वो मतलब नहीं है जो अब तक बन रहा था. So it's not just word level, it's even sentence level. पूरा sentence तारीफ में कहा, इतनी अच्छी मैंने कोई movie अपनी जिंदगी में नहीं देखी, but and that means कि आपको काम खराब होने लगा. Right? So context छोड़ दिया उसने, but you can still do interesting things. Like for example, if I ask you, what was this document about? What was the general field? जो इसमें yondra क्या थी जो discuss हो रही थी? Okay, now if it has electrical engineering words, you can say it's a technical document. If it has French words, you can do language recognition. So there are many tasks in NLP that you can reliably do. You may be able to tell roughly who the author was, because वो author ये word बहुत use करता है. Interestingly, जब हम इसकी details में जाएंगे, you will see that just using this chopped up schema of that document, we can reliably state the gender of the person who wrote it, their first language, वो उर्दू बोलने वाले अंग्रेज थे या अंग्रेजी बोलने वाले अंग्रेज थे या पंजाबी बोलने वाले अंग्रेज थे. So their L1, the language जो उन्होंने अपने formative years में सीखी थी, the topic, the genre, and many other things, emotions and so on and so forth. So just at the level of your one hot vectors and bag of words, which in the first sight looks like a completely useless form of representation, allows us to do lots and lots of forms of NLP, goals of NLP at a fair bit of accuracy. तो ये इतना बुरा नहीं है. So हमेशा आप ये याद रखना है कि हम there will be times जब हम गरीब होंगे computationally. हम हमेशा सबसे अच्छे मॉडल्स अफोर्ड नहीं कर सकेंगे या सबसे अच्छी रिप्रेजेंटेशंस अफोर्ड नहीं कर सकेंगे. हमें पता होना चाहिए कि हमारे टूल बॉक्स में जो जो कुछ है वो कितना पावरफुल है. So that's why our first stop in the course would be these bag of word models. However, we can fairly argue कि bag of words के अंदर meaning कोई खास नहीं था. So therefore, in order to bring in meaning, we add in this new aspect. By the way, this was a game changer. This 2013 word to vec. By the way, this idea was not new at all. You'll find that in 1950s, 1940s, इस चीज का जिक्र होता हुआ, where you're essentially saying, how can I represent meaning of a word? What is the meaning of a word? What is the meaning of the word bottle? What's the meaning of the word? Okay, there's a mental picture. Yeah, but that's not words. There is the definition of the dictionary. Sure. But another really interesting way of defining, or at least going close to, the meaning of a word is to find its neighbors. So words, whenever they occur, naturally in text, tend to have some specific neighbors. Not everything occurs in the neighborhood of everything else. You want proof? He turned his homework dash. खुदा के वास्ते मुझे अंग्रेजी पे embarrass ना करना अपनी. I'll be very happy fixing many of the things in your computer science background, but you should know this continuation. He turned his homework in is a good continuation. Give me another one. He turned his homework over. He turned his homework. No, that's not grammatical. He turned his homework around, which has a strange meaning. But okay, from here we go into two directions. Continuations which are grammatical and continuations which are grammatical and sensical. Not all of them belong to all categories. There will be continuations which make a lot of sense and are also grammatical. There will be continuations which are grammatical, are they work fine for a different noun. They just don't work fine for homework. He turned his homework blue. Grammatical, perfectly grammatical. He turned his bunny blue. He painted it, whatever. But homework के लिए बात जरा अजीब है. He turned his homework down. This is almost like I offered the homework to you and you turned it down. You want a homework? Nah. So that works for proposal. He turned his noun down. He turned his proposal down. Fine. He turned his homework down. Would be grammatical but nonsensical. Not directly sensical at least. Okay, how about he turned his homework fish? He turned his homework wall. He turned his homework is. He turned his homework the. Turned his homework an. Neither grammatical and nor it is making any sense. So there are certain words which are more probable in this context than other words. This context excludes some potential neighbors and includes some potential neighbors. So the context tells us something about who can fill this gap, who can fill this blank. This is the basic idea of your vector embeddings or your word to vec. Word to vec was essentially words are known by the company they keep. So if you want to define the meaning of a word, you look at the company of the word. Now, when we do this, and when we're going to do this, again, मैंने कहा था ना वादा किया था किसी डिटेल में नहीं जाऊंगा, डेप्थ में नहीं जाऊंगा. So जब हम ये करने के लिए बैठेंगे तो हमें पता लगेगा कि हम एक्चुअली सिनोनिमी तक नहीं पहुंच सके, ऐसे वर्ड्स तक नहीं पहुंच सके जिनका मानी सेम हो. अगर नेबर सेम है तो जरूरी नहीं है मानी सेम हो. हम उसके लिए एक नया वर्ड बनाते हैं, हम उसे कहते हैं वर्ड सिमिलैरिटी. So coffee and cup have the same neighbors in text, but coffee and cup do not mean the same thing. But coffee and cup have the same environment, have the same ecosystem. They are similar words. They are not words which have the same meaning or even similar meaning, right? They go with each other. Okay? All right. So ये हम पढ़ेंगे आपकी पहली पहली वाली जो रिप्रेजेंटेशन है, which is the one hot vectors or the bag of words, ये उससे बेहतर करने के लिए हम बना रहे होंगे. So this is the first place where your neural network is going to make its appearance. Okay, here is how we do it. We say, maybe I have a good image for you. Yeah, I do have a good image for you. All right. How do we train these word-to-vec embeddings? What we do is simply, we take two words, let's say cat and cute. We try to train a model to predict whether they're good neighbors or not. So on a scale of 0 to 1, be closer to 1 if they are good neighbors, they go together, and be closer to 0 if they are not good neighbors, they don't go together. The two words simply should not be together. वो होता है ना वो शादी से पहले, if anyone किसी को वो जो अंग्रेजों की शादी में किसी को एतराज है कि दोनों बंदों को साथ नहीं होना चाहिए तो अभी बोले वरना हमेशा खामोश रहे. It's like that. So neural networks speak out if these two should not be together. So the neural network says like 0.0. Yeah, okay, 0.01. Yeah, okay, you have a problem with that. Okay, so we find the actual neighbors from text जो सचमुच में है, and words which are never in the neighborhood of each other, give them to the neural network, train the neural network to fit this model, and by doing so जो उन words की representation है वो continuously update हो रही होती है through your back propagation. This new thing which is being created is now treated as the feature vectors. So your embeddings come out as a byproduct of training your neural network to predict whether a pair of words is similar to each other or not, are good neighbors or not. When it starts doing really good prediction, we find that in the hidden layers, we have something which is a really good and a dense representation of those words. ठीक है, so वो जो आपकी sparse representation बनी थी, वो sparse representation यहाँ आकर फिक्स हो जाती है. Here you define कि मैं कितना बड़ा रखना चाहता हूँ इस hidden layer को, और इस hidden layer के size में मैं ये define कर लेता हूँ कि ये मेरा नया vector है जो बनेगा. काफी सारे question है, let me take them one by one. सर आप पहले. Yes, शाबाश. So we need a window size. Good, sir. जी जी जी, जितना ज्यादा डार्क कलर है उतना ज्यादा वो वाले वर्ड की वैल्यू हाई है. सो डार्कर इज क्लोजर टू 1 एंड लाइटर इज क्लोजर टू 0. This is just a visual representation of a vector. Sir. Yes, but we don't need to. Here we are specifying the size of the hidden layer. हमारी मर्जी है, हम जितना बड़ा उसे बना दें उतना बड़ा वेक्टर ट्रेन हो जाएगा. ठीक है. How often they are together? Yes, we will do that. We're going to start with that. So we're going to start with some representations like SIBO, continuous bag of words, and glove, जिसके अंदर हम यही काम कर रहे होंगे. So SIBO glove में यही करेंगे, उसके बाद जो उससे ज्यादा थोड़ी sophisticated embeddings आएंगी उसके अंदर फिर हम ये वाला काम करेंगे. And we'll see why that is important. वही सीन है, साथ आते हैं, लाइट एंड डार्क एक ही जगह आता है, शाबाश, बिल्कुल। ऑपोजिट्स जो है वो ऑपोजिट्स आर एक्चुअली वेरी सिमिलर वर्ड्स, they're actually as similar as possible because there is just one attribute which is opposite for them. So the word man and the word woman, if you look at the attribute space of that, is exactly the same except for the gender attribute. So yeah, the opposites are actually very similar words. Ji. Shabash. Great. Amazing questions. Let me add to your question. How do we even deal with words which have multiple meanings? The word bank, for example. When we have trained a particular embedding representation of the word bank, that could either be the peso wala bank or the river wala bank. Yeah, in the worst case, both, which is not a good representation because now usko pata hi nahi hai main kaun sa hu. Meaning mein main kiske kareeb hu. Do I go closer with fish or do I go closer with dollar? उसे पता ही नहीं है इस बात का. तो लिहाजा this is where your word embeddings as word to vec they start failing because it's missing something which is the context in which it's being used. So word to vec does not have that context. The next model will fix that. It will have that context. जी. Yes. हमें प्री ट्रेंड अब मिलते हैं लेकिन हम आपसे पहली दफा ट्रेन करवाएंगे ये चीजें. So essentially the first time when you train it you just take pairs of words and you start predicting only the data set that you're working on. The bigger the data set, the better the embeddings. Let me actually show you something. This is what it ultimately represents. It does not always do that nicely, but this is what it usually does. Words which are closer to each other have similar meanings, and words which are farther away from each other have different meanings. So apple and banana go together, cats, dogs, puppy go together, buildings and houses go together, adult and baby go together, man and woman go together. So the words which have some similarity in meaning are closer to each other. So this is the first time that we update our representations to have a semblance of meaning. ये बेसिकली वो जगह है जहां हम आपसे वो पेपर पढ़वाएंगे जिसके ऊपर वो सारी लड़ाइयां पड़ी थी. मैन इज टू अ डॉक्टर एज वुमन इज टू अ इन द मॉडल सेड नर्स. और उसके बाद वो मारा, हमने बहुत कूटा उस मॉडल को, उसके पास बड़ा गुस्सा किया था हमने उसके ऊपर. ये भूल करके वो मॉडल हमारे ही डेटा पे ट्रेन हुआ हुआ है. मॉडल बेचारे की कोई गलती नहीं थी, तो काउंट करके बता रहा था, उसको क्यों मार दिया पकड़ के. बट या सो दैट्स वेयर दैट इज. इट डज नॉट ऑलवेज डज दिस मीनिंगफुल रिप्रेजेंटेशन नाइसली बिकॉज. अच्छा, अब मैं इसकी ना आपको, ओके, लेट मी गिव यू अ मेंटल पिक्चर एज वेल. सो दैट यहां तक अगर कोई चीज समझने में कमजोरी रही है तो लेट मी गिव यू दिस इंट्यूटिव मेंटल पिक्चर. ओके, think of a meaning graph. Think of this room as a huge 3D graph where things are plotted by their meaning. So suppose I take a word table and I plot it here, and I take a word chair because chair and table उनके environment एक जैसे होते हैं, it will be close here. I take a word desk, it will be closer to the table than chair because desk and table have exhibit a synonymy in some senses. By the way, and again maybe शायद मैं बाद में दोबारा repeat करूंगा, in any language there are no real complete synonyms that exist for a long period of time. One of them dies off. The only reason why synonyms exist is that in some senses they're synonymous and there's some other senses in which they are not synonymous. Your big sister said this. Your huge sister said this. Big and huge are synonymous, but not in this context. Big sister is fine because big shares meanings with elder. Huge does not. So ये भी एक, so we will keep exposing these, but yeah, let's go back to the meaning graph. Okay, so you start plotting the words here, but then you get the word fish, which goes over there, which has its own neighbors, like I don't know, the oyster and the sea and whatever, and so the words keep coming in like that. Okay, what are the dimensions of this graph? What should be the dimensions of this graph? So what word to vec assumes is that the dimensions of this graph is the vocabulary of the language. So your table is high on the wood word scale. Word wood के वो एक्सेस पे काफी आगे है क्योंकि अक्सर टेबल्स वुड की होती हैं. लेकिन वो फिश के एक्सेस पे बहुत लो है क्योंकि टेबल फिश नहीं होती है, या हो सकता है होती हो क्योंकि टेबल पे फिश रखी जाती है. So this is how word associations lead to a semblance of meaning. So this is basically it. And this also allows your multilinguality and multimodality in many senses. So by the way, वो घड़ी गलत है, पूरे 5 मिनट अभी रहते हैं. पीछे किसी ने नहीं उस घड़ी को देखना है. इसमें 2:03:10 हुए हैं. 5 minutes left. एक सेकंड पहले नहीं छोड़ूंगा. Okay. All right. So, okay. What was I saying? Multilinguality. Okay. You take the word kursi, you map it into this meaning graph. The kursi, if the dimensions had the combined vocabulary of Urdu and English, the kursi and the table will have similar position in this graph. The maze and the table will have similar positions in this graph. Now you dive into the graph through kursi and come back out with its nearest neighbors, you have translation. So as soon as you have your embeddings, it opens up pathways of doing really, really interesting stuff. Okay, let me make it even more scandalous. Okay, images have meaning. You take an image of a table, you extract the meaning. It says maze. You put it in the graph. It gets plotted somewhere. You take another word, an image of a chair, put it into this graph. Now go in through the word, come out through the image. You have text to image, not generating as yet, just the image, or image to text just by doing a nearest neighbor search. You're doing no more than a k nearest neighbors, and you're achieving things as sophisticated as text to image to text, and text to text translation. ठीक है, at a very very basic level. अभी अभी इसमें वसत नहीं है लेकिन कर रहा है. ओके, मैंने कुछ मिस तो नहीं कर दिया पिछले पे? हाँ, इसकी आपको जरूरत नहीं, खुद से पढ़ लीजिएगा. जो कुछ मैं बीच में छोड़ रहा हूँ, you're reading the chapter, by the way. You know that you're reading the chapter. Okay, all right. So there are many types of embeddings. अभी तक हमने जितनी बात की वो वर्ड्स की embeddings थी, वर्ड्स की representations थी. Embeddings could also be defined at sentence level. We can have sentence embeddings. When will that happen? When will that happen? When you tokenized at the sentence level. If your tokens are sentences, then the learned embeddings are sentences which come in the neighborhood of other sentences. You can also have document level embeddings. Why would I need a document embedding? Who would need a document embedding? What kind of a program would need a document embedding? Who needs to retrieve documents? A search engine. Search engine does not care in many cases about the words, it cares about the document because it's retrieving the document, not the words for you. आपका Google आपको पूरे पेज का लिंक ला कर देता है, unlike your ChatGPT web search which gives you words extracted from that web page. So as long as आप document retrieval कर रहे हैं, your document embeddings are more relevant and more contextually important than your word embeddings. ठीक है? All right? Okay. यहां तक का जो सबसे बड़ा प्रॉब्लम आया वो ये था कि मानी तो आ गया, लेकिन ये लफ्जों का मानी है और इसमें लफ्जों का कॉन्टेक्स्ट इंक्लूडेड नहीं. इट डज नॉट हैव द कॉन्टेक्स्ट ऑफ द वर्ड इन देयर. सो your bank will always have the same embedding. Therefore, this allows us to enter into the world of more sophisticated forms of neural network. So this is where we're going to say temporary goodbye to your feed forward neural networks. Very temporary, because afterwards they made such a great comeback that now they're the thing. They're the alpha network. But for a moment, for many years, they were not the thing. So we will start looking at this whole framework, which we call the encoder decoder framework. And initially we will be introduced to this framework by using the example of translation. So say I have a sentence in Urdu, मैं खाना खाऊंगा, और मैं इसको अंग्रेजी में ट्रांसलेट करना चाहता हूं, I will eat. For this, I need to represent मैं खाना खाऊंगा in some form and then start outputting the output sentence I will eat which is not just looking at what the input sentence was, but also looking at what partial output I have already produced. So the model needs to understand a lot of things. So the way this works is by using something which we call an encoder. Encoder के आगे आपको ब्रैकेट में एक चीज लिखी नजर आ रही है, ये भी आपको आपके ख्वाबों में आएगी, और अच्छे या बुरे ये उन ख्वाबों में आएगी जितना आपने इस पे मेहनत की होगी. ये वो जगह है जहां पे मैंने इन सारे सीक्वेंस मॉडल्स का मैथमेटिक्स करना है. So if you struggled with your back propagation, wait until I do the back propagation through time with you. The fancy name. I love this name always. This is the only time when I feel like a physicist who's working on time travel. So back propagation through time. Yeah. So this is a type of a neural network which we call a sequence model. It has the ability to remember what has been processed up until now. So it can do a word by word processing or token by token processing. So we use this to create a representation of the sentence मैं खाना खाऊंगा. So it forms a combined representation. That representation does not have just representations of individual words, but also the context. We'll see how. And then it gives that representation to something else, which is called a decoder. By the way, जो आपको अपनी स्क्रीन के सामने जो तस्वीर नजर आ रही है, ये तस्वीर यहां से लेकर चैट जीपीटी तक सेम रहनी. इसकी सिर्फ तफसीलात बढ़नी. चैट जीपीटी जब आएगा तो इस ग्रीन हिस्से को हम उतार कर फेंक देंगे, सिर्फ लाल को रख लेंगे, which is the decoder. Your GPT is a decoder only model. Your BERT is an encoder only model. Your T5 is an encoder decoder model. So translation models take in a sentence, convert it into a representation. So think of like this. एक sentence लिया, उसे उठाकर एक डब्बे में बंद किया, उसकी पूरी representation को, और उसको किसी और को दिया, और उसने उसको देखकर target language के अंदर words निकालना शुरू कर दिए, one word at a time. दिस इज द मैकेनिज्म जिसको हम अगली क्लास में एक्सप्लोर करना शुरू करेंगे. आपसे जो मेरी देखिए, मैं शुरू शुरू में बहुत अदब से ही दरखास्त करता हूँ, फिर मैं क्विजेज लेने लगता हूँ. तो आपसे दरखास्त ये है कि साथ साथ चैप्टर 1 पढ़ना शुरू कर दें. इट्स वेरी रीडेबल, लाइक इट्स लाइक अ बेड टाइम स्टोरी. सोने से पहले पढ़ रहे होगे ना, एक एक चीज समझ आ रही होगी. इट्स वेरी रीडेबल. तो जस्ट स्टार्ट रीडिंग द चैप्टर 1. बुक मिलेगी कहाँ से वो ढूंढ लो, बहुत जगहों पे अवेलेबल है. ईमानदाराना तरीकों से खरीदना, लेकिन शायद जस्ट डिस्कस अमंगस्ट योरसेल्फ. थैंक यू सो मच.